We're going to finish chapter 7 today on different proportions in similar triangles. And I will give you the funniest theorem of the year, the side splitter theorem. Okay. So, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides them proportionally. So in this example right here from this guy, since these are parallel, then we know that PR over RU is proportional to TQ over TS. So the side they split proportion. And then the converse is also true. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if this proportion is true, then I also know that the line is parallel. And that idea of converses and conditional statements and theorems that we learned at the very beginning. Let's go ahead and solve for these. I'm going to put my X here. And these ones are nice and easy to set up. So I have a line here, and I put equal. There's my proportion. So I can just pop that up. 4 over 8 equals X over 2. I should be pretty good at solving these proportions. This one. Again, I'm going to reduce. I get 1 over 2 equals X over 12. Cross multiply. QX equals 12. Divide both sides by 2. X equals 6. Now this one, I want to check to see if they're parallel. So I can check the converse of our side splitter theorem. There's our equals right there. So if I flip it around, I get 56 over 21. It equals 48 over 16. If this is true, then I know those lines are parallel. Remember I showed you a couple different ways to see if a proportion is true. The first, we can reduce those fractions to see if we get equal numbers, equal fractions. Or I can just divide with my calculator and see if I get equal things on both sides. Or the last way, probably the easiest, cross multiply and see if we get the same numbers. So does 56 times 16, does that in fact equal 21 times 48? If that's true, I know they're proportional and those lines have to be parallel. We have 896 does not equal 1008. These guys are not. Okay. All right, take a second. See if you can do examples 3 and examples 4. And just a word to the wise so we don't make a mistake. For this one, we don't need to use those side splitters, right? We can't use that side splitter theorem from up above. Because do we have these guys right here? We don't have either of these. So set these up using similar triangles. Similar triangles. Okay? These are triangles, then we'll go over it. This one over here, example 4, you can't use what we learned about. All right, so this first one, I need to set up just as they are typical similar triangles. Okay? So I know that we have one triangle both on top. So I have X and 9. What goes with this X on this big one? This whole side. X plus 9. And what goes with the 9 here? The 15. Essentially, I have two similar triangles by angle, angle. You have right angles here, and they share this angle up here. So we know that this triangle here where we have x and 9, is similar to this larger triangle here. We're at 15 and x plus. All right, so let's solve for x here. Because this whole side, this is x, this is 9, added together is the length of the whole side.
But how do you know that? Like, when do you?
I need to know this length right here. This section's 9, this section's x. The whole thing is their sum, adding them together.
On the one side.
So that's this small triangle side. So now I'm going to simplify by both top and bottom by 2. Cross multiply. 5x equals 3x plus 27. Subtract 3x from both sides. If 2x equals 27, divide both sides by 2. X equals 13 and a half. This next one, I can set up just like this. Line equals line. So I get x over x plus 4 equals 12 over 18. Given that these two segments of this triangle are parallel, we know that the sides are divided proportionally. Divide top and bottom by 6. X over x plus 4 equals 2 over 3. Cross multiply from there. We get 3x equals 2x plus 8. Subtract 2x from both sides. X equals. If you cross multiply at the very beginning, you're going to end up with the same answer. Said it, did you get it? Yeah, good job. All right. Two other ones. So corollary to the side splitter here. Now if I have 3 parallel lines intersect 2 transversals, so I don't even have triangles here, then it divides the transversals proportionally. So let's look at example 5 real quick, and then we'll come back to this second. So I want to find ST, so I'm going to put an X right in there. And this is just like our side splitter theorem problems. Put your line here, set an equal line there. There's our proportion we need to solve. Cross multiply here. 9x equals 15 times 11. Oh, wait. Mistaken me. I don't want to cross multiply first. I want to go ahead and simplify first. Well, I can take a 3 out of both of those. Then I should cross multiply. So I get 3x equals 55. And how many times does 3 go into 55? Goes into 5 once, with 2 left over. 3 goes into 25 8 times. 1 left over. So 18 and the third. In your calculator is 55 divided by 3. All right, the next one. This is kind of like the ones we looked at in the last class in right triangles. I typically like to go ahead and refer to this picture up here. Okay, to solve these type of problems. So if I look right here, I have this triangle. All right. So now we have an angle bisector in a triangle. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So the way I deal with these ones, right? I'm going to put one triangle, both on top, and then the other triangle, both on bottom. So I have AD, this guy right here, and with that triangle, CA goes right there. And then this other triangle, it's a little tricky with what matches up, right? It's going to be the sides that are right next to each other that match up. So the DB goes with the AD, and then the CB goes with the CA. So these two kind of correspond, and then these two. So get in the habit of using these pictures to go ahead and solve problems. So let's go ahead and see if we can go ahead and do this.
We'll go about first, second. Thank you.
All right, let's look it down here. So I want to solve for AD. Put an X there. And it's all about setting up the proportion. I believe most of you are pretty good at cross multiplying and solving a proportion. But setting it up tends to be the challenging part, especially when I look at your quiz. So let's look at one triangle first. Look at this triangle here. I'm going to put my X and my 9 on top. Which one goes with the X? So this triangle both on bottom. What goes with the X is the 10. What goes with the 9? The 15. Simplify and then cross multiply. So divide top and bottom by 3. Cross multiply here. 5x equals 30. Divide both sides by 5. X equals 6. So AD up there has a length of 6.